Hi everyone, let's do this question. If a square minus b square is equal to 120, how many pairs of a comma b can you form such that a comma b are positive integers? Pause the video, give it a try, and then let's do this together. Alright, we are back. I hope you have given it a try, and do remember, if you have not already subscribed to this channel, subscribe and hit the bell icon and comment below I subscribed and I will personally reply to you. Alright, now let's get back and solve this question. As per the given statement over here, we know a square minus b square is equal to 120, and we know that a square minus b square can be rewritten as a minus b into a plus b. So a minus b into a plus b is equal to 120. Alright, and we need to find how many such possible pairs of a and b can be formed, and it's given that a comma b are positive integers. So that's the question. Now let's get started. Now a good way to approach this is we can get started by checking in how many ways can I write 120 as the product of two numbers. Alright, so let's just go ahead and see how many ways we can do that. So I can write 120 as 1 into something, right? 1 into 120 itself. Alright, what about 2 into something? Can I write 120 as 2 into something? Yes, it can be 2 into 60, right? What about 3 into something? Yes, that's possible. It's 3 into 40, right? And again, we know that 120 is divisible by 3 because the sum of the digits over here is divisible by 3, right? So 1 plus 2 plus 0 is 3. So 120 is divisible by 3. So again, yes, I can write 120 as 3 into 40. Okay. What about 4 into something? Yes, that's also possible. 4 into 30, right? So 4 into 30 gives you 120. In a similar manner, you can just try in how many ways you can do this. So again, notice that among a plus b and a minus b, because a and b are positive integers, a minus b will be the smaller one, right, compared to a plus b. So that's why when I write 1 into 120, I'm writing the smaller number over here. So I have 1 into 120, 2 into 60, 3 into 40, 4 into 30. Similarly, 5 into 24, 6 into 20, and I don't have 7 into anything because if you divide 120 by 7, you won't get a whole number, right? So there is nothing with 7, and then you have 8 into 15, and you don't have anything with 9. Again, the same reason, if you divide 120 by 9, you don't get a whole number. And then you have 10 into 12, right? 10 into 12 also gives you 120, and you don't have anything with 11. So, and again, after that, it'll just reverse, right? So if you want to write 120 as a product of two numbers, you can again, after this, write it as 15 into 8, but that's just a repetition of what we have over here. And again, as we mentioned, we want to write the smaller number on this side where we have a minus b. So these are the different possibilities. Now, one way of solving this is you could take all these pairs where a minus b is 1 and a plus b, for example, is 120, and you can solve and find the value of a and b and check whether they are positive integers. But a better way for solving this is, let's try to take a minus b as p and a plus b as q, two different variables. All right, now you can notice an interesting thing over here. When you add p and q, you will get a minus b plus a plus b, that's equal to 2a, right? So a is actually p plus q divided by 2, and in a similar manner, b is equal to q minus p divided by 2. Again, let's just try that. If you do q minus p, that's a plus b. Let's just write that over here. That's a plus b minus and then p, right? P is a minus b, so you're subtracting a minus b from it, and you can see that this a and this a will get cancelled when you open the bracket, and you will be left with b plus b, which is 2b. So when you divide that with 2, you will get b. So a is equal to p plus q by 2 and b is equal to q minus p by 2. All right, and again, we know that a and b are positive integers. So all you need to do is, over here, you just need to add and subtract these, right? So if you want to get p plus q, you need to add these two. And if you want to do q minus p, you have to do this minus this, right? And when you do that, whatever you get should be divisible by 2. If that is satisfied, then it holds, right? So let's go through these solutions over here and try it in each case. So over here, if I add and if I try to find p plus q, that's 1 plus 120, which is 121. And q minus p will be 120 minus 1, which is 119. Now over here, you can see that these two are not divisible by 2, right? So if you were to take these as the values of a minus b and a plus b, when you find a and b, they will not be positive integers. They'll be having some decimal value, right? So this is not a possible solution. Similarly, what about 2 and 60? If I add, I get 62, and 60 minus 2 gives me 58, so that's fine. What about the next one? 3 plus 40 gives me 43, which is not divisible by 2, right? So again, I can stop over here. I don't even need to find this the subtraction part, because again it has to be that p plus q and q minus p has to be divisible by 2. So this is definitely not a possible solution. What about 4 and 30? So you get 34 and 26, which is fine, right? Because both of these are divisible by 2. And in the next case, you get 5 plus 24 as 29, so that is not fine. And after that, you get 26 and 14. So these two are divisible by 2, so that's good. And then you have 8 and 15, right? So that's 23. So again, it's not divisible by 2, so this is also out. And over here you have 10 and 12, so that's 22 and 2. These two are divisible by 2, so yes, that's valid. So we have these 4 cases where we are getting p plus q and q minus p as divisible by 2. So yes, these are the 4 cases where it's possible. So again, we don't need to find the exact values. We just need to know how many such pairs are possible, right? And again, we can find out, right? If you wanted to find out, you just need to divide by 2. So in this case, a would be this by 2, which is 31. And in this case, that would be 58 divided by 2, right? Which would be 29. So you can find it out, but we don't need to. We just need to know how many such possible pairs are possible. All the best in your preparation.